Okay, so picture this. You're trying to build like this super advanced security system, right? And it uses machine learning to stop attacks, like before they even
Right, it's
happen.
a precog system.
Yeah, exactly. It's like that's the future we're always hearing about, right?
Right.
But what if I told you that those systems, even when they're built by experts, they could end up being less secure because of mistakes in how they use machine learning?
Oh, yeah. There are some sneaky dangers in using machine learning for security stuff.
That's what we're diving into today.
And you know what's funny? Even pros overlook them sometimes.
Really?
Oh, yeah.
Yeah.
Luckily, though, researchers are figuring these pitfalls out, so we're going to try to help you understand them.
That's awesome.
Okay?
So we're looking at this paper today called Do's and Don'ts of Machine Learning in Computer Security, and it was presented at a pretty big security conference.
Oh, yeah. That's a good one.
So it's got to be legit, right?
Yeah, for sure.
That's like a cheat sheet for anyone who wants to know how machine learning is changing security.
Yeah, and the researchers looked at a bunch of top security studies,
Ew.
and they found something kind of alarming.
Look at that.
Almost every study had at least 3 major pitfalls in how they were using machine learning.
3. Wow, that's a lot.
Yeah, it's a lot, right? But the interesting thing is they grouped these pitfalls based on like the stages of building a machine learning system.
Okay, so break those stages down for me.
All right, so first you got to collect data to train your system right.
Right.
Then you design the system itself.
Okay,
Make choices about the type of learning you want to use.
gotcha.
Then you evaluate how well it works.
Okay.
And then finally, you actually deploy it in the real world.
Makes sense.
And each stage has its own pitfalls.
Okay, so let's start with data collection.
Okay.
Seems pretty simple at first.
Right. Just gather a ton of data
Yeah.
and let the machine learning do its thing.
Exactly.
Well, not so fast.
Oh,
The biggest trap is something called sampling bias.
sampling bias.
Yeah, it means the data you're using to train the system, it needs to like accurately reflect the real world.
Gotcha.
If it doesn't, your system's going to learn the wrong things.
So it's not just about the amount of data.
No.
It's about
It's about the quality.
making sure it matches the real scenarios.
Exactly. Like imagine teaching someone to drive in like a quiet neighborhood
Right.
and then expecting them to handle rush hour in a big city.
Yeah, that's not going to go well.
Yeah, total disaster.
So one example they looked at was Android malware detection.
Right.
And researchers were using this huge data set called AndraZoo.
Yeah, AndraZoo, it's massive.
But the problem was that most of the malicious apps in AndraZoo came from certain markets,
Right.
while like the benign apps came from other places.
Yeah.
So if you're building a system to detect these malicious apps
Right.
and it's trained on data that's skewed like this,
Yeah.
what happens?
It might just learn to flag apps from those certain markets as suspicious, even if they're not actually malicious.
So it's just going off of where it came from.
Yeah, kind of like training a dog to sniff out drugs, but you accidentally teach it to just bark at anyone wearing a certain type of shoe.
Oh, I see. So that's a problem.
Yeah, big time.
How do researchers deal with this sampling bias then?
Well, getting rid of it completely is tough.
Yeah, I bet
The
it
key is just awareness.
makes sense.
Researchers got to be careful about how they collect their data,
Okay.
make sure it really represents the real world.
So even with good data, there's still a chance my machine learning system might learn the wrong things.
Yeah, that's right.
What other pitfalls should we watch out for?
Another one is label inaccuracy.
Okay.
So, like, imagine you're teaching a kid to recognize animals, but you accidentally label a picture of a dog as a cat.
Right.
That wrong label is going to confuse the child.
Right.
Same thing can happen with machine learning.
So is that a big problem?
It's not as common as sampling bias,
Okay.
but it still happens, especially in security research.
How so?
Well, sometimes we rely on things like antivirus engines to label whether a file is malicious or not.
Right.
But those engines, they don't always agree.
So if the labels are messed up,
Yeah,
that can really throw things off.
exactly. It can introduce bias and lead to inaccurate results.
What's the solution then?
Well, the best way is to manually check the labels,
Right.
but that takes forever.
Yeah, I bet.
Other options are to use models that aren't as sensitive to noise in the labels,
Okay.
or develop even better labeling methods.
Okay, so it's all about making sure that the starting point is accurate.
That's it.
Makes sense. Okay, so we've talked about data collection.
Right.
What about designing and training the system?
All right, so this is where things get kind of interesting,
Okay.
because there are some sneaky pitfalls here.
Like what?
The first one is data snooping.
Data snooping, what is that?
It's basically when you accidentally give your model a sneak peek at the test answers before the exam.
Like cheating.
Yeah, exactly. You accidentally leak info from the test data into the training process.
So it's getting an unfair advantage.
Yeah, it makes the model look way better than it actually is.
So how many ways can you data snoop?
Oh, there are a few ways. There's test snooping, temporal snooping, and selective snooping.
Okay, break those down for me.
So test snooping is when you use the test data to adjust the model's settings before you do the final evaluation.
Oh.
It's like giving a student the same practice test as the real one,
Right.
and then being surprised that they get an A.
Gotcha. What about temporal snooping?
This one's really important in security.
Why is that?
Well, because threats are always changing, right?
Yeah.
And temporal snooping is when you ignore the time dependencies in your data.
Like using old data to predict new threats.
Exactly.
Right.
Like training a malware detection system on data from 5 years ago and then testing it on today's malware.
Yeah, good luck with that.
Right. And then there's selective snooping.
Okay.
That's when you clean your data in a way that wouldn't be possible in the real world.
Give me an example.
Like, imagine you remove outliers based on information you wouldn't actually have when the model is actually running.
So it's all about making sure the training process is fair
Yes.
and the model doesn't get any extra help.
No peeking allowed.
Right, exactly. What other pitfalls are lurking in this design and learning stage?
Okay, get ready for this one. It's called spurious correlations.
Spurious correlations.
Yeah, it's when your model gets tricked by patterns that look important but actually mean nothing.
Oh.
It's like thinking all red cars are fast.
Because you've seen a couple that are.
Yeah.
I see. So my system could be basing decisions on totally irrelevant stuff.
Exactly. Like, imagine a system that's supposed to find vulnerabilities in code.
Right.
But it gets fixated on, like, the length of variable names.
Really?
Yeah, and then it might flag totally safe code as dangerous.
That's because the variable names are too short.
Yep.
Okay, so it sounds like these small details can really mess things up.
Oh, yeah, for sure. And that's why it's super important to address it.
So how do we do that?
Well, luckily, researchers are working on these explainable learning techniques.
Oh, yeah, I've heard of those. What are they again?
They basically help us understand why the system is making certain decisions.
So we can see inside the black box.
Exactly.
And make sure it's not making decisions for the wrong reasons.
You got it. And speaking of understanding those decisions, there's another pitfall related to this.
Oh, what's that?
It's called biased parameter selection.
This sounds complicated.
It is a bit technical,
Okay.
but it's basically about making sure the settings of your model are chosen fairly
Okay.
and don't depend on peeking at the test data.
So again, no cheating.
No cheating. It's another form of data snooping.
Gotcha. So how do you avoid that?
Same solution. Keep the test data separate.
Don't let the model see it.
Right.
Okay, so we've talked about data collection. We've talked about system design.
Yeah.
Where do we go from here?
Now it's on to performance evaluation.
Okay.
Or see how well our model actually works.
All right. So are there more pitfalls?
Oh, yeah, you bet. More pitfalls to watch out for.
It's like we're on a treasure hunt.
Haha. Right.
But instead of finding treasure, we're finding all these pitfalls.
Exactly. And the first one we need to talk about is inappropriate baselines.
Okay, I'm listening.
It's all about making fair comparisons.
Right.
Let's say you build this new security tool,
Okay.
and you want to show that it's better than what's out there.
Right.
You need to compare it against those existing
This
methods.
is like a benchmark.
Exactly. Those are your baselines.
Okay.
But if you choose weak or irrelevant baselines,
Yeah.
you might make your tool look better than it actually is.
Ah, so it's like bragging that you can outrun a snail.
Uh-huh. Yeah, exactly.
Okay, so how do you make sure you're using the right baselines?
You got to do your research.
Makes sense.
Make sure you're comparing your work to the best methods out there.
Got it. What other performance evaluation pitfalls are there?
The next one is all about choosing the right way to measure performance.
Okay.
It's called inappropriate performance measures.
Okay.
It's easy to focus on stats that look good on paper, but they don't always tell the whole story.
All right, give me an example.
Okay, imagine a malware detection system that says it has 99% accuracy.
Wow, that sounds pretty good.
Right. But what if that 1% of missed malware is actually thousands of infections?
Oh, I see.
That's the problem with just focusing on accuracy.
Yeah.
It doesn't give you the whole picture.
Especially with something like cyber attacks.
Right, exactly. So sometimes metrics like precision and recall are better than just looking at overall accuracy.
Okay, remind me what those are again?
So precision is about minimizing false positives.
Those are the annoying false alarms.
Yeah, exactly.
And recall is about minimizing false negatives,
Right.
which means making sure you don't miss any real threats.
You got it.
Okay, so it's
Yeah.
all about finding the right balance.
Yeah.
You don't want to be too sensitive
No.
and set off a bunch of false alarms.
Right.
But you also don't want to miss the real threats.
Exactly. It all comes down to choosing the right metric for the specific problem.
Got it. And that leads us to another pitfall, the base rate fallacy.
Ah, yes, that's a good one.
Tell me about it.
This one is about misunderstanding how the rarity of an event can mess with our perception.
Okay.
It's especially important in security.
Why is that?
Well, because we're often dealing with things like intrusion detection,
Right.
where attacks are pretty rare compared to normal traffic.
Okay, so how does this base rate fallacy work in the real world?
Imagine you have an intrusion detection system that's 99% accurate.
Okay, sounds good so far.
Right. But if attacks only make up a tiny fraction of network activity,
Okay.
like let's say 0.1%,
Right.
then that 1% error rate
Yeah.
could still lead to a ton of false alarms.
Oh, I see. So even a really accurate system
Yeah,
could be sending out all these false alarms.
exactly.
Because the event it's trying to detect is so rare.
Exactly. You got to keep that base rate in mind.
And choose metrics that aren't thrown off by those rare events.
Right.
Got it. Okay, so we've got inappropriate baselines, inappropriate performance measures,
Right.
base rate fallacy.
Yet.
Anything else hiding in the shadows of performance evaluation?
There's one more.
Oh, lay it on me.
And it's a big one. It's lab-only evaluation.
Lab-only evaluation.
Yeah, it's the idea that a system might work great in a lab,
Okay,
but then completely fail in the real world.
I see. Kind of like how self-driving cars sometimes struggle in real-life situations.
Exactly.
So give me a security example of this.
Network intrusion detection is a great one.
Okay.
Researchers often test these systems using really simplified data
Okay.
that doesn't actually reflect the complexity of real network traffic.
So it passes the test in the lab,
Right.
but it might not work in a real network.
Exactly. It's like testing a self-driving car on a track with no other cars and then expecting it to handle rush hour traffic.
Yeah, it's not going to end well.
Right. So it's super important to test these systems in realistic settings whenever you can.
But how do you do that?
Well, that's the tricky part.
Right.
It's not always ethical or practical to test things out on a live network.
Right? You can't just unleash a new security system on a live network and see what happens.
Uh-huh. Yeah, exactly.
So what do researchers do?
Well, they're always working on ways to make those tests more realistic. They're
Right.
developing more sophisticated data sets and simulation environments that can mimic real-world conditions.
So it's about finding that sweet spot between controlled experiments
Yeah.
and real-world chaos.
Exactly.
Okay, what about that final deployment stage? Any pitfalls there?
Oh, there's one that might keep you up at night.
What's that?
It's inappropriate threat models.
Okay, explain.
So this one is all about remembering that machine learning systems,
Okay.
they can be attacked, just like any other computer system.
Wait, hold on. So you're saying that in addition to using machine learning to protect against attacks,
Yeah.
I also have to worry about attackers going after my machine learning system.
Yeah, I know. It's kind of crazy.
That's kind of terrifying.
But it's the reality.
So what kind of attacks are we talking about here?
There's a whole category called adversarial machine learning,
Okay.
where attackers specifically target the machine learning process itself.
So they're not just going after the data.
No.
They're going after the system that's supposed to be protecting the data.
Exactly. They can mess with your training data,
Oh, wow.
trick your model into making bad predictions.
Oh, no.
You could even steal your model's secrets.
So any part of the machine learning process is vulnerable.
That's right. And a lot of studies just forget about this.
They just assume the system itself is secure.
Right. They forget that it needs to be protected too.
So what can we do to protect against these attacks?
It's tough, but it all starts with awareness.
Okay.
Got to think like the attackers
Right.
and try to anticipate how they might try to mess with our systems.
So it's about building security into every single step of the process.
Yes, from data collection to model training to deployment,
Always be on guard.
always on guard.
Okay, we've covered a lot of ground here,
Yeah, we have.
and it feels like we're just scratching the surface of this paper.
There's a lot to it, that's for sure. But even though these pitfalls sound scary, the researchers didn't just point out the problems.
Yeah.
They offered solutions.
Okay, that's good to hear. I was starting to get a little overwhelmed by all the doom and gloom.
I know, right?
So there is hope for building secure and reliable machine learning.
Absolutely. And that's what we'll dive into in part 2 of this deep dive.
Okay.
We'll look at how researchers are tackling these problems
Awesome. I can't wait.
and building more robust systems that we can actually trust.
Sounds like a plan. I'm ready for some good news. All right, so last time we went through a bunch of pitfalls
Yeah, a lot of them.
when it comes to machine learning and security,
Right.
and it was kind of a bummer.
It was a little doom and gloom, I know.
But I'm ready for some good news now.
Okay, I hear ya.
Like, how are people actually fixing these problems and building systems that we can trust?
Okay, well, one of the best things that researchers are using is actually simplicity. Yeah, sometimes a simple approach can be better than all the fancy machine learning stuff.
Huh. Interesting. So, what is a simple approach better?
Well, especially when it comes to security. You know?
Okay.
Remember that intrusion detection thing we talked about?
Yeah, where the simple method beat the complex one?
Yeah, exactly. That was crazy, right? The box plot method.
Yeah, the box plot method. I couldn't believe it.
I know. It just shows you that sometimes the best solution isn't the most complicated one.
Yeah, that's a good point. Sometimes simple is better.
Right, and that's something that all researchers should remember.
Yeah, don't overthink it.
Right.
Okay, so how do researchers know when to go with the simple solution?
Well, you really got to understand the problem you're trying to solve.
Okay,
You need to look at the security challenge
right.
and think about the good and bad things about different ways of solving it.
So basically choose the right tool for the job.
Exactly. Sometimes all you need is a hammer, right?
Right. But sometimes you need a more precise tool. What are some other solutions that researchers are trying out?
Well, another really important thing is to understand what your model is actually learning.
Okay.
Remember we talked about explainable learning?
Yeah, that was fascinating, like being able to see inside the black box.
Right. And by understanding that, researchers can spot those tricky correlations that can really mess things up.
Those spurious correlations.
Yes.
The ones that make the model focus on the wrong things.
Exactly. It's like having a security expert explain their thought process.
Right.
You can check their logic.
And make sure they're not making bad assumptions.
Right.
That seems so important for building trust in these systems.
Absolutely.
So knowing how the system works is key.
Yes.
Okay, so we've got simplicity and explainable learning.
Right.
What else?
Well, another important solution is to design systems with attacks in mind.
Oh, right. The
Oh.
whole inappropriate threat model thing.
Yeah, that's the one.
The one where we have to remember that the machine learning system itself can be attacked.
Yes, exactly.
It still freaks me out a little.
I know, it's kind of scary. But researchers are starting to think like attackers.
Really?
Oh, yeah. They're trying to find ways to break their own models.
That's so smart. So they can find the weaknesses before the bad guys do.
Right. It's like playing chess against yourself to figure out what your opponent might do.
I like that analogy.
Mm-hmm.
So it's about being proactive
Exactly.
instead of just waiting for an attack to happen and then trying to figure out what went wrong.
Exactly. It's about being one step ahead.
Love it.
Yeah.
Okay, so we've talked about simplicity, explainable learning, and designing for attacks.
Right.
What else is out there?
Well, there's also a lot of work going on to improve the training data.
Oh, yeah. How so?
Well, remember how we talked about sampling bias?
Yeah, where the data needs to be a good representation of the real world.
Exactly. And researchers are trying to figure out ways to collect better data.
Okay.
Data that is a better reflection of what's actually going on out there.
So it's not just about having more data.
No, not at all.
It's about having the right kind of data.
Yes. It's got to be balanced and unbiased.
Got it. But that's got to be tough, right? Especially in security.
Yeah, it can be.
How do you get real-world data on cyber attacks?
That's the challenge, right? You can't exactly go around collecting data on illegal activities.
Yeah. That's a good point.
So researchers are getting creative. They're working with companies and government agencies
Oh, right.
to try and get access to real-world data.
That makes sense.
But they have to do it in a way that protects people's privacy, of course.
Of course.
Yeah.
So it's about finding that balance between real-world data and protecting people's information.
You got it.
Okay, so these are some pretty high-level solutions. Can you give me some specific examples of how these are being used?
Sure. Remember that Android malware example?
Yeah.
The one where the models were getting tricked by those correlations?
Yeah, they were basically learning to tell the difference between apps from different app stores.
Right. They're focusing on where the app came from instead of whether it was actually malicious.
Exactly. So how did researchers fix that?
Well, instead of training one big model on all the data,
Okay.
they started training separate models for each app store.
Oh, it's interesting.
So each model specializes in a particular market,
Right.
and it learns what malicious behavior looks like in that specific market.
It's really clever, like having a team of detectives who each specialize in a different area.
Exactly.
What about vulnerability detection? Any progress there?
Oh, yeah, definitely. Researchers are getting better at dealing with those correlations that can trick models into thinking harmless code is dangerous.
Oh, right, like the Voldypecker example, with the buffer sizes,
That's the one.
where the model was focused on the wrong thing.
Right. So now researchers are using things like attention mechanisms.
Attention mechanism.
Yeah, they basically help the model focus on the parts of the code that are actually important.
So it's like giving the model a magnifying glass.
Haha, exactly. So it can see the details that matter.
I love that.
Oh, that's
That's
fun.
so cool. So are these attention mechanisms working?
They're showing a lot of promise. Vulnerability detection is getting more accurate.
That's awesome. It sounds like researchers are making some real progress here.
They are.
What about those adversarial machine learning attacks?
Oh, yeah. Those are tricky ones.
The ones where attackers target the machine learning system itself?
Right. But researchers are developing some cool defenses.
Like what?
Well, one promising approach is adversarial training.
Adversarial training. What is that?
It's basically like giving the model a little bit of the poison so it can build up immunity.
So you're exposing the model to the attack
Yeah,
so it can learn how to defend itself.
exactly. It's like giving someone a small dose of a virus so their body can learn to fight it off.
I get it.
That's brilliant.
Right. So by doing this, researchers can make their models much stronger and more resilient to real-world attacks.
That's so cool. It feels like researchers are really starting to fight back against these attackers.
They are. They are. And they're also working on detection mechanisms.
Detection mechanisms. Yeah, these are tools that can spot when a model is being attacked.
Oh, like an alarm system.
Exactly. It's like having a security guard for your machine learning system.
I like it.
And these detection mechanisms can really help to reduce the damage from an attack.
This is all so fascinating. It feels like we're really at the beginning of something big with machine learning and security.
We are. It's an exciting time.
But it's also clear that there are still challenges ahead.
Oh, yeah, definitely. We've got to be realistic about what machine learning can and can't do.
Right. And keep researching and developing new solutions.
Exactly. But I'm optimistic about the future. With more research and careful development, we can use machine learning to make the world a safer place.
So we've learned about a lot of pitfalls
We have.
when it comes to machine learning and security.
Yeah, a lot of things to watch out for.
But we've also talked about some really interesting solutions.
Right, there's some really cool stuff going on.
It feels like we're at this exciting point
I think so too.
where machine learning is changing the way we think about security.
Yeah, definitely changing the game.
But it's also clear that there are still some big challenges ahead.
Oh, for sure. We've still got a lot to figure out.
So what are the key takeaways for anyone working in this field?
Well, one of the most important things is to be transparent.
Transparency.
Yeah, you got to clearly explain what you did,
Okay.
how you did it,
Right.
what data you used, how you evaluated your results, all of that.
So basically, be open about your process.
Exactly. That way other people can understand your work. They
Right.
can try to reproduce it.
Right. And make sure your findings are legit.
Exactly. And it also makes you think more carefully about your own work.
How so?
Well, if you know you have to explain everything clearly,
Okay.
you're more likely to catch any mistakes you might have made.
Right. So it's like a built-in quality control.
Exactly. It forces you to be more rigorous.
I like that. What else?
Another important takeaway is to choose the right evaluation metrics.
Oh, yeah. We've talked about that before.
Yeah, it's really important. Don't just focus on accuracy.
Right. There are other metrics that might be more important.
Right, exactly. You got to use metrics that actually make sense.
Right. For the security problem you're trying to solve.
Exactly. Think about what really matters in the real world.
Not just how well your model performs in a lab.
Right. And don't be afraid to admit when things don't go as planned.
Oh, you mean like when your model fails?
Yeah. It's tempting to just sweep those failures under the rug.
Right. No one likes to talk about their failures.
But in security, understanding those failures can be incredibly valuable.
Okay. How so?
Well, those failures can tell you a lot about where your model is weak,
Right.
and they can give you clues about how to improve it.
So it's not just about celebrating your successes
No, it's about learning from your mistakes.
and using those mistakes to make your system stronger.
Exactly. And one last thing.
Okay, what's that?
Never forget to think like an attacker.
Ah, right? the whole inappropriate threat model thing.
That's the one. You always got to be thinking about how someone might try to exploit your system.
Right, so don't wait for an attack to happen before you start thinking about security.
Exactly. You got to be proactive. Find the weaknesses before the bad guys do.
So it's about shifting from a defensive mindset to an offensive one
I like that. Always be on the attack.
when it comes to security, right?
Exactly.
Well, this has been a fascinating look at the world of machine learning and security.
It has been. Lots to think about.
We've covered a lot of ground.
We have.
We've talked about the pitfalls, the solutions, the challenges, the opportunities.
It's a really exciting field, that's for sure.
It really is. And it feels like we're just at the beginning.
I think so too. There's so much more to discover.
So what's the one big takeaway from all of this? What should our listeners remember?
I think the most important thing to remember is that machine learning is a powerful tool,
Right.
but it's not a silver bullet.
It's not going to solve all our problems.
Exactly. It's a tool that we need to use carefully.
Right, with a lot of thought and awareness.
Exactly.
Yeah.
We need to understand its potential, but also its limitations.
So basically, approach machine learning with a healthy dose of skepticism.
Yeah, I like that. Be skeptical, be curious, and always be learning.
Great advice. Well, thanks for joining me on this deep dive into the world of machine learning and security.
It's been my pleasure.
And thanks to all of you for listening. If you want to learn more about this, be sure to check out the research paper. We'll link to it in the show notes.
Yeah, check it out.
And until next time, stay curious and stay secure.